Hello everyone. We're going to be doing some notes on one-step equations, and I know that some of you have definitely done this before, so I would like to focus on a few of these equations with integer numbers, but if you look down your notes, you're going to notice that I'm focusing more on fractions on purpose to keep practicing with them over and over. So let's get started, shall we? Make sure you have your notes in front of you so you can take them along with me, and again, I hope this video was helpful to you. So a lot of you have been asking me, should I solve this? When we've been doing distributive property and combining like terms, you've been saying, should I solve? Should I get x by itself? And the answer, the only time that you are going to solve something is when you see an equation or an equal sign. Any of these. If you ever see an expression like 2x plus 4 plus 6x, all I'm asking you to do is to combine like terms, make that 8x plus 4, but there's nothing else you can do there. However, in an equation, our goal is to get the variable alone. So for number one, what we want to do is say, what is the best way to get d isolated? And if I see d minus 8, that means to me that, well, what is the opposite or the inverse of subtraction? Well, if you're thinking addition, I agree with you completely. And so we're going to add 8 on both sides of the equation, because whatever you do to one side, you must do to the second side. How do I know I did this right? Well, negative 8 plus 8 crosses out to be combined to be a 0. So we're just left with d equals 17 plus 8, which would get me a good old answer of 25. Number 2. If we are trying to get m by itself, this time 71 is keeping it from being isolated. And this time we're adding, and the opposite of, or the inverse of addition is subtraction. And so we would subtract 71 on both sides. These again would cross out to combine to be 0. So we'd have m equals. Then we'd have to think about what negative 16 and negative 71 combine to be. And those add or combine to be a negative 87. If this notation bothers you, feel free to flip it to be m equals negative 87. The lovely third example. I don't know about you, but I'm staring at this double negative and saying, good Lord, that must be changed. So I'm going to make that into a big old plus, make it 8 plus n equals 1. And then just like the previous problem, my goal is to get n isolated, and I see addition. The inverse is subtraction, so I'm going to subtract 8 from both sides and get n equals 1 minus 8, or negative 7. Moving onward. Fraction time. Good times indeed. If we would like to get w isolated, what we need to do is move this 3/2 because it's on the same side as w, and it's being subtracted. So the first thing I'm thinking is if we add 3/2 on both sides, these still combine to be 0 because you got a positive and negative of the same thing. So we have w equals, and I'm going to write it horizontally, 1/4 plus 3/2. And as we've been working on, when we add fractions, we need a common denominator. And so you could multiply this first fraction by 2 and this one by 4. Or you might notice that the greatest common denominator is 4. So you could multiply the second fraction by 2 over 2. And if you do so, you would get w equals 1/4 plus 6/4. So my answer would be a positive 7/4. And yes, please leave your answer improper. Number 5, your goal is to get j isolated, and that 5/8 is in the way. And so this time we're adding. So to get it to the other side, we have to subtract. These combine to be 0 and cross out. So we have j equals negative 4/7 minus 5/8. In order to subtract, we again need a common denominator. The first number that 7 and 8 go into is 56. So I could use that trick of multiplying this fraction by 7 over 7 and multiplying this fraction by 8 over 8. And if I do so, 8 times negative 4 is negative 32. J equals 8 times 7 is 56, minus 5 times 7 is 35. 8 times 7 is 56. So if I would like my final answer, remember the denominator has to say 56. And the numerator, if I combine a negative 32 and a negative 35, that would be a negative 67. So my answer as an improper fraction is negative 67/56. Moving on from addition and subtraction, let's deal with some multiplication division, shall we? So if we take a look at number 6, again, when there's nothing between the number and the variable, you assume that there is multiplication occurring, and the inverse is division. And so if we want to get the negative 13 to the other side, because it's hindering my variable being alone, we divide by negative 13. So we have z equals negative 39 divided by negative 13. Well, first, negative divided by a negative is a positive, and second, 39 divided by 13 is a positive 3. Number 7. If you're annoyed with the variable being on the other side, you definitely can switch this around. You could change it to be 15m equals negative 180 if you'd like, and then the problem reminds me of the previous one, that if your goal is to get m by itself, you're going to isolate the variable by dividing by 15, because we're currently multiplying. So m would become negative 180 divided by 15. Negative divided by positive is a negative. 180 divided by 15 is 12. So my answer is negative 12. Number 8. Now this time, it's just the notation that's strange. But remember that a fraction here is really just division. So if your goal is to isolate a, and that 15's in the way, you are going to do the opposite of division, and you're going to multiply both sides by 15. And if you do that, these 15's, a multiplied and divide 15, cross out, and you're left with a equals, and I'm just going to write it out the long way, 4/5 times 15. But as I talked about yesterday, remember that this is really 15 over 1, so if you like it, you could multiply straight across. Some of you might notice the cross canceling, but let's multiply across first. 4 times 15 is 60, 5 times 1 is 5. Does 5 go into 60 evenly? Why, yes it does. The answer is 60 divided by 5, or 12. How convenient that both of these had a 12 in it. And remember here, I love this problem so much because you had multiplication of fractions, which does not need any common denominator at all. Hurrah for that, right? Number 9. Now, we have a 1/5 in front of the p, which is a bit of a hindrance. But this problem and this problem actually don't end up being too different. If I want to get rid of a fraction quickly, remember that a fraction really is just division, so we could think about multiplication. Now, what I want you to do is write down the word reciprocal, because it comes in very handy at this time. I want to point out that 15 over 1 is the reciprocal of 1 over 15 here. So if I come over here, if I have 1/5 and I need to get rid of the 1/5 because I need to get the p isolated, if we multiply this side by 5 over 1, the 5's are going to cross out and so are the 1's. But whatever I do to this side, I have to do to this side as well. So over here, if we multiply by that lovely reciprocal, the 5's cross out, the 1's cross out, so I'm left with p equals 3/5 times 5 over 1. Some of you might notice that the 5 on top and bottom completely cancels out, so I'm left with just p equals 3. If you didn't notice that and you went through the multiplication the long way and did 15 over 5, you would still get 3. So this idea of a reciprocal only occurs when you are multiplying or dividing. It does not apply when you're adding and subtracting. Last set of problems then. Number 10, 11, and 12. A couple of them have to do with fractions, and I hope this pace has been decent for you. Again, feel free to go back and rewatch any of this if you need to. If I were looking at number 10, I would say that J has two annoying things by it. It has the 12 and the negative. But the 12 is being divided, so I'm thinking the first thing we should do is multiply by 12. But if we want to do 2 birds and 1 stone, let's multiply both sides by not just 12, but a negative 12. Because if I multiply both sides by negative 12, the 12's cross out, and so does that little negative there. So I'm left with just J equals negative 8 times negative 12, and negative 8 times negative 12 is a positive 96. The next example, again, I'm just going to flip it because I see it easier this way. -3/2 k equals 12. And here we are multiplying a fraction, so the idea of the reciprocal might come back to help us. My goal is to get k alone, and so let's think reciprocal. The reciprocal of 3/2 is 2/3. So I'm going to multiply, let me change colors. I want to multiply this side by 2/3. And if I do that here, I also want to multiply this side by 2/3. Also, because I want to get rid of that negative, let's multiply by a -2/3. So over here, the 2's cross out, the 3's cross out, and the negatives cross out. And we're left with k equals 12 times -2/3, which is really 12/1 times -2/3. If you want to go straight across, that would be 12 times -2, -24/1 times 3, 3, or even more simplified, -8. Last but not least, number 12, which has some just truly lovely things in it, the fact that I gave you a mixed fraction. And as you might remember from an earlier lesson, this is easier if it's improper. The one interesting thing, though, is what we want to do when we change this to an improper fraction is actually ignore the negative. So let's pretend a minute that this negative is not here. If we want to change this to an improper, that would be 3 times 8, 24, plus 1 is 25/8. After you change the fraction to an improper, that is when you worry about your negative. So now I'm going to put the negative back. So I'm going to write a note, ignore the negative when changing a fraction from mixed to improper. I wish that was a little bit neater, my apologies, but what it says again is ignore the negative when changing a fraction from a mixed number to an improper number. So if I come back up here, and for the sake of it, I'm just going to erase this and make it into a different color, just so everyone can see it a little better. We said that this was -25/8. H equals 4. And so if I want to get h alone, we need to multiply by the reciprocal again. So I'm going to bring that down here for more room. Let me rewrite it. -25/8 h equals 4. And so if I multiply this side by the reciprocal, because we want to get h alone, so we need to move this, we multiply this side by -8/25, and we multiply this side by -8/25. On this side, the 8's cross out, the 25's cross out, so we just have h equals 4 times -8/25, which is really 4/1 times -8/25. I don't see any cross canceling we can do, so we're just going to multiply straight across, no common denominator needed, and our answer would be -32/25. All right, guys, so that's the end of the video. I'm going to be giving you a practice worksheet for tonight that's focusing mainly on working with fractions because I find that those need a lot more practice in the long run. So hopefully you are going to get that sheet from either myself or Mr. Foster, and you can start working on it if you have time in class. Thank you for watching, and again, feel free to use this as a resource.